Hey everyone, welcome to Particles in Motion 4. Okay, determining the distance a particle travels. This is Nicholas JMV. You can see I've recorded a few videos today. Same hat I had on when I did the tabular Riemann sums video. So I'm just kind of all over the place today. So let's look at a couple of examples. We're going to look at distance. It's important we're not looking at total distance, but particles in motion comes up a lot in AB. Now, for our first example, how far does the particle travel between the 8th and 10th seconds if its position function is given by x of t equals t squared minus 6t. So we're actually going to look at the first derivative. We're going to see where this particle comes to rest. So x of t is equal to t squared minus 6t. It means the derivative is equal to x prime of t of 2t minus 6, or we can factor out that 2 there, and we get 2 times t minus 3. Now we're going to set it, when does this particle rest? Because we got to know that. So 0 equals 2 times t minus 3. So our particle's at rest, or could be at rest, when t equals 3. If I look at the sign line, okay, I'm going to plug 3 here. And I notice that whenever I plug in a number greater than 3, this is always going to be positive. Anything less than 3, I'm going to have something that's negative. Okay? Now this is really important because now we want to know when the particle's traveling between the 8th and 10th seconds. Now this particle is always moving right. Okay, so we can set it up by just using the position function. We can just look at the distance. Okay, the distance it travels as x of 10, right, 10th second minus x of 8. Now this is going to work in this particular case because the particle is not going to change directions. It's positive from there on, and we're looking at the 8th and 10th seconds. This is after 3 seconds. It's positive. It's not turning around. I can't just do x of 10 minus x of 8 if the particle changes direction. It's very important you realize that. So when I plug these in, I get 10 back into the position function, 10 squared minus 6 times 10, or 100 minus 60, okay, for this, minus, okay, now I got to plug 8 in. 8 squared is 64, 64 minus 8 times 6 is 48, okay. When I do that, I end up with my result of 40 minus 16, which I get a distance of 24. So that's how far that particle traveled in from 8 to 10 seconds. Okay. So if you have any questions or comments on this one, the next video I'm going to show you is when the particle can change direction. So we'll see you next time, guys.